Hi there, let's deal with our first topic in heat and temperature, which is looking at different temperature scales and thermometers. The first thing we need to talk about is the following. Temperature and heat are not the same thing. Heat, or sometimes called thermal energy, is actually different than temperature. When we measure the temperature of something, what we're really doing is we're taking a measure of how fast the particles are moving in an object. So if both these pots were at the same temperature, let's say 60 degrees Celsius, and this one's at 60, what would we know about these two pots of water when it comes to temperature? They'd be moving, all the particles would be moving at the same speed. They'd be vibrating with the same amount of motion. However, what can we say about the amount of thermal energy in each of these two pots? It's not the same. Thermal energy is the number of particles and the average speed of those particles, which is actually just the temperature. So heat or thermal energy depends on the temperature and how many particles. So let's look at these two pots again. Which of these two pots has more heat energy or thermal energy? Well, when we look at the temperature, same temperature. How about when we look at the number of particles? The big, huge pot has more particles, and therefore overall it would have more thermal energy. Thermometers measure temperature either mechanically or electronically. Most mechanical thermometers are based on the fact that they will expand when heated and contract when cooled. One type of mechanical thermometer, the liquid in glass, has usually it's no longer mercury, now it's alcohol. And there are three temperature scales that might be on a thermometer depending on where you are. The empirical system, and that's used in the United States, would have a Fahrenheit scale. The metric system, which is used in most other parts of the world, has a Celsius scale. And the scientific scale is Kelvin. We don't have to know how to go from Fahrenheit to Celsius, but we should be aware of the relationship between degrees Celsius, which is metric, and Kelvin. 0 degrees Celsius is equivalent to 273 Kelvin. So let's say it was 10 degrees Celsius. What would that be in the scientific scale, which is Kelvin? 273 plus 10. So 283 Kelvin. How about 40 degrees Celsius? What would that be in Kelvin? Well, add 40 to 273, and that would be 313 Kelvin. K for Kelvin. Here's the anatomy of a typical mechanical thermometer. Instead of mercury, which is kind of poisonous and toxic, we use rubbing alcohol, and there's a bore inside. And what happens is this liquid, when it's heated, will expand, take up more space, and rise higher up, and it'll contract when it's cooled. Sometimes we use bimetallic strips, which I'll get into, and sometimes we use electrical thermometers called thermocouples. I know it says thermoresistor, but it should say thermocouple. So way back when, Galileo came up with something called a thermoscope, and this was one of the first thermometers. The problem with the thermoscope, it would have a bead that would go up and down, but we couldn't really tell how hot or how cold something was until we figured out how to calibrate a thermometer. So to calibrate a thermometer, you need two fixed points. that you know already what the temperature is. So we already know that ice melts at 0, so let's stick a glass tube in there. The mercury or the alcohol will go down, we make a mark, and we call that 0. Now we stick it in a second temperature that we know what the temperature is, and the alcohol rises, and we make a mark and we call that whatever. In this case, we know that water boils at sea level at 100. Now we just take a ruler and we make even marks along here, and we're done calibrating. Here's the thermocouple. They're used in really hot places like in ovens, where normal mechanical thermometers would just break or explode. And what that does is it converts electricity into a temperature reading. This is a clinical thermometer. It has a really narrow range because body temperature hovers around 37 degrees Celsius. So a narrow scale. This is a bimetallic strip. This person heated the strip and it bent this way, and they heated it and it bent this way. What we know about bimetallic strips, they're made of two different metals. And one of the metals, usually copper, will expand and stretch out at a faster rate, always causing it to curve. So copper would always be on the bottom here. And on the inside would be a different metal, aluminum maybe. So we use bimetallic strips in lots of places, and one of them is inside a thermostat. So let's look at how a thermostat works. Here's our bimetallic coil. Mercury is always used in a thermostat because it'll conduct electricity, but it's still liquid at room temperature. So the bead of mercury right now is away from the electrical contacts, so there is no electricity running through these wires that go down to the basement or wherever your furnace is. So these wires go to your furnace and help turn a switch on in your furnace. So the gap means the furnace right now is not on. The furnace is off. However, in wintertime, if the furnace is off and it's cold outside, eventually the house will cool down. What will happen? This bimetallic coil will start to contract and get smaller, and that will cause this glass tubule to tilt this way, which means the bead of mercury is going to slide down and it's going to cover up the two electrical contacts. Once it does, electrons can move through, or electricity can move through, and the furnace will turn on. Then the room will get hot and hot. Eventually that will cause this bimetallic coil to expand again, and when it does, the glass tubule tilts the other way and the bead of mercury slides back. And so that's a quick overview of how that works. Let's look at this clip on temperature.
Dear Tim and Moby, what's temperature? From Zach. All the matter in the universe is made out of tiny particles called atoms, which can be combined into slightly larger particles called molecules. Atoms and molecules are on the move all the time. All this molecular movement creates heat energy. Temperature is a measure of heat, or how fast those molecules are moving. The more you heat something, the faster the molecules move. This is what causes its temperature to rise. There's really no such thing as cold. Cold is just an absence of the molecular motion that causes heat. Boiling water has a higher temperature than cold water simply because its molecules are moving around more. Temperature is measured using a thermometer. There are three main scales by which temperature is measured. The Celsius or centigrade scale is the most widely used, and it's based on the behavior of water. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. The Fahrenheit scale, used primarily in the United States, is a little less straightforward. Pure water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. The Kelvin scale is a favorite of scientists because it begins at the absolute coldest anything can get. This temperature is also called absolute zero, and it equals 0 kelvins. At absolute zero, all molecular motion stops. There's always some molecular motion, so you won't ever actually see absolute zero. Deep space gets close, but even there, the cosmic background radiation from the Big Bang keeps things slightly above 0 kelvins. More temperature stuff? Heated gases expand, making them less dense. Air near the Earth's surface is heated by sunlight striking the ground. This warm air rises, and cooler, denser air from higher in the atmosphere sinks down to take its place. The warmer air cools off, and the cooler air warms up, creating a convection current. That